Scientists have recently discovered that beneath Mercury's surface, a thick layer of diamonds might be present, buried deep within the planet, possibly hundreds of miles down. This revelation coincides with the impending close-up observation of Mercury via orbit, as space agencies prepare to gather detailed data. When considering the possibility of life existing on other planets, it is essential to understand how the environmental conditions of these planets could shape the characteristics and forms of potential life. Mercury, a small planet located near the Sun, has been hiding substantial secrets that are only just starting to be uncovered. Despite its small size and intense heat, Mercury has been deceiving us for years, but robotic missions are now shedding light on its strange and mysterious features. The discovery of diamonds on such a harsh planet is just the beginning, and scientists are eagerly exploring what else this planet might be hiding. With its inner structure differing from previous expectations, Mercury raises intriguing questions about how it compares to other planets in our solar system. Astronomers and space fans alike have been fascinated by Mercury for many years. As the smallest planet in our solar system, it has long kept its landscape and internal workings concealed. However, with the progress in space exploration technology, secrets are finally beginning to surface. NASA's Mariner 10 mission in 1973 began the quest to learn more about Mercury's surface, followed by the Messenger spacecraft in 2004, which continued this research. Mariner 10, which provided our first close-up images of the planet, revealed a surface riddled with craters and unique lines similar to those seen on the Moon. It also showed that Mercury's surface was rough and pocked with craters, but it also had a stronger magnetic field than anticipated, along with a larger-than-expected core. These unexpected discoveries force scientists to rethink previous assumptions about Mercury's composition. The Messenger mission, which stands for Mercury Surface, Space Environment, Geochemistry, and Ranging, launched 31 years after Mariner 10, was designed to orbit Mercury and allow scientists to study the planet in greater detail. The mission generated over 200,000 images of the planet, offering new perspectives of Mercury's surface that had never been seen before. One of the more surprising findings was the unusually high levels of calcium and magnesium found on the planet's darker side, sparking curiosity about the geological processes responsible for these elements. Another remarkable revelation was that Mercury's magnetic field was stronger in the northern regions compared to other planets, which further raised questions about the planet's internal makeup. Unlike Earth and most other planets, which have magnetic fields generated by liquid iron movement in their cores, Mercury's magnetic field is powered by a distinct core structure. Mercury's surface is not only marked by craters and lines, but also by extreme temperature shifts. During the day, temperatures can soar to over 800 degrees Fahrenheit, 427 degrees Celsius, hot enough to melt lead, while at night, the temperature drops to minus 330 degrees Fahrenheit, minus 201 degrees Celsius, creating extreme fluctuations. These temperature variations are largely caused by Mercury's very thin atmosphere, which does little to moderate heat or maintain stable conditions. In spite of these harsh conditions, recent studies have uncovered even more surprising features on Mercury's surface. In 2012, data from the Messenger mission indicated evidence of volcanic activity, including pyroclastic deposits from explosive eruptions, contradicting previous assumptions that Mercury was geologically inactive. Additionally, in 2020, scientists discovered water ice present in some of Mercury's polar craters, areas that remain in permanent shadow and stay cold enough to preserve water ice despite Mercury's close proximity to the Sun. This revelation led to new theories about whether Mercury could harbor extremophiles, microorganisms that thrive in extreme environments similar to those found in the harshest places on Earth. The most recent mission to Mercury, named BepiColombo, was launched in 2018 by the European Space Agency and the Japan Aerospace Exploration Agency, with an expected arrival in 2025. This mission will provide further insight into Mercury's surface composition, chemical makeup, and geological history. From its unexpected magnetic field to the discovery of water ice, Mercury continues to challenge our understanding, with new research revealing even more unusual features. One of the most peculiar aspects of Mercury is the relationship between its day and year. Unlike the majority of planets, where the length of a year is shorter than a day, Mercury is an exception. A full year on Mercury lasts only 88 Earth days, while a single day, one full rotation, on the planet lasts 176 Earth days. This means that Mercury's day is twice as long as its year. This oddity creates fascinating effects. If you were to stand on Mercury, you'd witness the sun rise, grow larger, stop moving, reverse direction, and then continue on its regular course. This unusual motion occurs because Mercury's rotation is too slow to keep up with its rapid orbit around the sun. Mercury's slow rotation is thought to be a result of tidal locking, a phenomenon that slows a planet's spin over billions of years due to gravitational forces. However, unlike the Moon, Mercury is not completely tidally locked. Instead, it experiences a 3-to-2 spin-orbit resonance, meaning that for every 2 orbits it completes around the Sun, it rotates 3 times. This leads to extreme temperature variations, with one side of the planet facing the Sun becoming unbearably hot, while the night side remains frigid. These drastic temperature swings make it incredibly difficult for spacecraft to study Mercury, as they must navigate around its extreme day-night cycle and intense heat. The planet's thin exosphere, a layer of gases constantly replenished by the solar wind, nuclear decay, and micrometeorite impacts, also adds another level of complexity. New research suggests that Mercury's exosphere contains more water vapor than previously thought, likely formed when hydrogen from the solar wind mixes with oxygen in Mercury's surface rocks. In 2020, scientists discovered that Mercury's magnetic field is the result of a unique dynamo effect occurring within a liquid metal core, as opposed to the typical process seen on Earth. Despite its small size and slow rotation, Mercury's magnetic field is essential in protecting its surface from the solar wind, preventing its atmosphere from being stripped away, much like what happened on Mars. Another intriguing feature of Mercury is the hot poles, regions where the sun seems to pause in the sky. These regions are among the hottest areas on the planet, while areas near the poles remain in permanent darkness, cold enough to preserve water ice. The fact that these shadowed craters can store ice despite the planet's proximity to the sun raises important questions about Mercury's ability to host life. Some scientists speculate that these cold regions could also contain other volatile substances, like organic molecules, preserved in the planet's coldest craters. The combination of Mercury's strange day-night cycle and its unique spin-orbit resonance creates significant challenges for spacecraft. For instance, Bepi-Colombo had to perform multiple flybys of Venus and Mercury to slow down enough to enter orbit around the planet. Once in orbit, the spacecraft must carefully manage its exposure to Mercury's extreme heat during the day and conserve energy during its long cold nights. This balancing act emphasizes the harsh and unpredictable conditions on Mercury and the difficulties involved in studying such an extreme environment. New computer models suggest that Mercury may have once rotated much faster, but gravitational interactions with the Sun and impacts from large asteroids or comets have gradually slowed its rotation. These insights not only provide a deeper understanding of Mercury's history, but also offer clues about the formation and evolution of other planets in our solar system. As research into Mercury continues, even more questions arise. How does the planet's core remain partially liquid despite the extreme cold? How does its unique orbit affect its surface rocks? These deep questions remind us that there is still much to learn about Mercury and its role in the solar system. Though it is the smallest planet, Mercury is filled with enigmatic features that continue to captivate scientists. One of the most fascinating aspects is its unusually large core, which makes up about 85% of the planet's volume. Studies led by planetary scientist Dr. Nancy Chabot at Johns Hopkins University suggest that this large core may have been formed as a result of a massive impact in Mercury's early history. According to the hit-and-run theory, a large planetesimal could have collided with Mercury, stripping away its outer layers and leaving behind the iron-rich core we see today. Another puzzle is Mercury's magnetic field. Despite being small and rotating slowly, Mercury has a magnetic field roughly 1% as strong as Earth's, which was surprising to scientists who did not expect such a magnetic field from a planet of Mercury's size and rotation speed. Further investigations revealed that the magnetic field originates from a thin layer of liquid metal surrounding Mercury's solid core, challenging existing models of planetary magnetic fields. In 2020, scientists also discovered sulfur, potassium, and sodium on Mercury's surface, volatile elements that typically evaporate at high temperatures. These elements may have been brought to the planet by comets or asteroids, suggesting that the surface of Mercury might have evolved differently than previously thought. One of the most exciting discoveries is the presence of water ice in permanently shadowed craters near Mercury's poles, despite its proximity to the Sun. These cold regions allow the ice to remain preserved, offering scientists the opportunity to explore how water may have once played a role in Mercury's geological processes. Additionally, organic compounds have been found in these regions, raising the possibility that Mercury could harbor the building blocks of life. Despite its extreme conditions, Mercury's potential to support life is being reconsidered as new discoveries continue to unfold. The presence of water and organic molecules adds to the intrigue of this small planet, suggesting that it may not be as inhospitable as once thought. Mercury's role in the solar system is becoming increasingly fascinating. As each new study provides more insights into its unusual characteristics, scientists are constantly challenged to reconsider their understanding of how planets form and evolve. One key area of research is the study of Mercury's internal structure and magnetic field. Unlike most planets, Mercury's magnetic field is generated by a dynamo effect within its liquid core, which protects its surface and helps to maintain its exosphere. Bepi-Colombo, which is set to arrive in 2025, will continue this important research by mapping Mercury's surface and studying its magnetic field and geological history. This mission will expand on the work done by the Messenger spacecraft, which mapped the planet in greater detail than any previous mission. By refining our understanding of Mercury's composition, magnetic field, and geological history, Bepi-Colombo will offer valuable insights into the solar system's early days. The mystery surrounding Mercury's oversized metallic core, its hollow features, and the possibility of diamond-like carbon compounds could help scientists unlock the secrets of planetary formation and evolution across the solar system. Despite the many challenges posed by Mercury's extreme environment, each new discovery brings us closer to understanding this fascinating and enigmatic planet. As we continue to explore the unknowns of space, Mercury stands as a testament to the mysteries that remain, offering clues to the forces that shaped not only the small planets like Mercury, but the entire solar system itself. The journey to uncover these secrets will undoubtedly lead to groundbreaking revelations that could change our understanding of planetary formation, the potential for life, and the history of our solar system. The exploration of Mercury is just the beginning, and as we prepare for the next phase of exploration, new discoveries will surely continue to unfold, unveiling the wonders hidden within this tiny yet captivating world. As scientists continue to probe Mercury's mysteries, each discovery adds a layer to our understanding of not only this enigmatic planet, but also of planetary science as a whole. One of the more surprising aspects of Mercury is its oversized metallic core, which has long intrigued researchers. This massive core, which makes up roughly 85% of the planet's volume, is unlike that of any other planet in the solar system. Many researchers believe that a colossal impact in Mercury's early history could have caused the planet's outer layers to be stripped away, leaving behind a disproportionately large core. This theory, known as the hit-and-run hypothesis, offers a compelling explanation for Mercury's strange composition. Despite its extreme proximity to the Sun and its small size, Mercury's magnetic field is another captivating feature. Even though the planet rotates slowly, it still generates a magnetic field, which was surprising to scientists when it was first detected. This field is thought to originate from a liquid metal core surrounding Mercury's solid interior. The nature of this magnetic field, which is about 1% as strong as Earth's, challenges previous models of planetary magnetism, as it seems counterintuitive that such a small and slow-rotating planet could produce a magnetic field. The fact that it does so sheds light on the complex dynamics within Mercury's core and raises questions about the planetary formation processes that could lead to such an anomaly. Another fascinating discovery was the presence of volatile elements like sulfur, potassium, and sodium on Mercury's surface. These elements are typically volatile at the high temperatures experienced on Mercury, leading researchers to reconsider how these substances could have been deposited on the planet. It's possible that they were brought there by impacts from comets or asteroids, meaning that Mercury's surface could have undergone different evolutionary processes than previously thought. These findings open new avenues for understanding how the planet's surface may have evolved and interacted with external forces throughout its history. Water ice has also been discovered in permanently shadowed craters near Mercury's poles, areas that are shielded from the sun's scorching heat. Despite Mercury's extreme temperatures, these regions have remained cold enough to preserve ice. The presence of water ice on such a hot planet is not only surprising but offers scientists an exciting opportunity to explore how water might have played a role in Mercury's past. This discovery also raises the tantalizing possibility that organic molecules could be preserved alongside the ice, suggesting that Mercury might harbor the basic ingredients necessary for life. While this doesn't necessarily imply that life exists on Mercury, it does point to the planet's potential to support life under extreme conditions, similar to the way extremophiles thrive in Earth's harshest environments. The ongoing exploration of Mercury, especially with missions like BepiColombo, will continue to provide critical insights into the planet's magnetic field, geological history, and chemical composition. BepiColombo, which is scheduled to arrive in 2025, is particularly significant as it will allow scientists to investigate Mercury's internal structure and its magnetic field in unprecedented detail. This mission will also shed light on the planet's surface features and provide further clues about its mysterious evolution. As we continue to learn more about Mercury, we are also gaining a deeper understanding of planetary formation and the unique characteristics of other celestial bodies in the solar system. Furthermore, as new technologies enable more advanced exploration, our ability to study Mercury's extreme environment will only improve. Understanding how Mercury's core, magnetic field, and surface interact with solar radiation and meteorite impacts will help scientists draw parallels with other planets, including Earth. For example, comparing Mercury's exosphere, a thin layer of gases around the planet, with Earth's atmosphere could provide valuable information about the processes that shape planetary atmospheres and how they evolve over time. This comparison could also lead to new insights into how Earth's atmosphere might change in the future and whether other planets have the potential to support life. In conclusion, the exploration of Mercury is far from over. The combination of its extreme environment, complex history, and unique features makes it one of the most intriguing objects in the solar system. As new missions and research continue to expand our knowledge, Mercury is revealing itself to be much more than just a tiny, scorching world. Its magnetic field, potential for water ice, volatile surface elements, and oversized core are just a few of the many aspects that challenge our understanding of planetary science. As the BepiColombo mission and future endeavors unfold, we can expect even more remarkable discoveries that will reshape our knowledge of the solar system's smallest planet. Ultimately, these findings could not only deepen our understanding of Mercury, but also provide essential insights into the broader processes that govern planetary formation, evolution, and the potential for life beyond Earth.